Part 3, Solving Exponential Equations. Solving an equation means to determine the value of the variable that makes the equation true. The problem with exponential functions is that the variable is an exponent. There are two methods that can be used to solve exponential equations. Well, two methods right now. Okay, the first one is rewriting bases. If the bases are the same or are powers of one another, okay, so that's kind of handy to know your times tables and your powers. Okay, we'll get into that in a minute. And then, of course, graphically. Okay, and this is used if the bases are not the same or are not powers of each other. Okay, so tell you what, part A, we're going to rewrite the bases. Okay, so here, express each of the following as base 3. Okay, so 81, okay, we're saying that 81 is 3 to the something. So 3 times 3 times 3 times 3. How many 3's is there? Well, of course, this one is 3 to the 4th equals 81. Okay, so then 1 over 27. Okay, the idea here is that 27 is 3 cubed. Okay, 27 equals 3 to the 3. But the problem is the base isn't 27. The base is 1 over 27. So remember, when you have this reciprocal thing, that's when you have the negative exponent. So this is 1 over 27 is 3 to the negative 3. Okay, so that base is 3 to the negative 3, and then it says to the 5th. Okay, remember how this works, or how this is going to work, is that we're going to rewrite the bases, okay, so that the bases are going to be equal, and then we simplify. So those exponents are going to multiply, so 1 over 27 to the 5th is exactly the same as 3 to the negative 15. Go ahead and try it on your calculator if you want. 1 over 27 to the 5th, and then type in 3 to the negative 15. You'll get exactly the same decimal. Okay, so then this next one is 3 root 3 to the x. Okay, so here's, both of these pieces are powers of 3. So 3 is 3 to the 1. Now root 3, you'll remember, is 3 to the half. Okay, to the x. Now remember, when you have two bases, so 3 and 3, okay, when you multiply same base powers, we add exponents. So 1 and a half, so 1 plus a half, 1 and a half, or 3 halves. So this is 3 to the 3 over 2. You could say 1.5 as well, but you're in Math 30-1. You should be using fractions. So, sorry if my writing was a little better for you guys. So that's 3. The base is 3. The exponent is 3 over 2. Okay, and that is to the x. So remember, that's fractions times a number, so that's just 3 to the 3x over 2, or 3 halves x. They're exactly the same thing. Okay, so that is that one. Now, D's a little tricky, because we've got 9s, we've got 81s, we've got roots, okay, all sorts of things. Not a problem. We still need to write everything as base 3. So the issue here, so 9 is 3 squared. So this is going to be 3 squared to the negative 3. Okay? Oh, I'm so sorry. That's a 2. Alright. So 3 squared to the negative 2. So, of course, those exponents multiply. So this first part is going to be 3 to the negative 4. Okay, now 81, we already learned back from A, that 81 is 3 to the 4th. Okay, now also remember that a cube root just is a fractional exponent. So I'm just going to write up here, guys. So 81 to the 2/3. Okay, so that is the 3 represents the cube root. Okay, so that's good. So this is going to be, so times, so 81 is 3 to the 4th, so 3 to the 4th times 2/3. Wow, that's intense. So now those two exponents multiply, so that's going to be 3 to the 8 thirds. 8 thirds. Okay, we have 3 to the negative 4 still over here. So now we have two powers that are multiplying, so we add exponents. And you don't need to be a hero here. Just you're adding exponents, so negative 4 plus 8 thirds on your calculator, that's fine. So this is 3 to the negative 4 thirds. Okay, so that, I know that was heady and hard. Go ahead and watch that again if you need to. Okay, but we separate the 9 into 3 squared. We separate the 81 into 3 to the 4th. Okay, the cube root is a third on the bottom, or a 3 on the bottom of the exponent, so 2 thirds. That's how that one worked out. Okay, so watch how we apply this now to these equations. When solving exponential equations, if the bases are not the same, but one is either a power of the other, or both are powers of a smaller base, we change the bases to be the same. Once the bases are the same, we equate the exponents and solve for the variable. Verify solutions by substituting answers back into the original equation. Okay, so I've got a few examples here for you. Now I am going to have to write fairly small for some of these, so if we get down to E and I need more space, I'll just make another blank page, but that's okay. You should be fine on your page. Okay, so solve the following for x. So let's make this a little bit bigger so we can see. There we go. That's better. Okay, so 10 to the x plus 4 equals 1,000 to the x minus 4. Okay, so the first thing we notice, 10,000 is a power of 10. 10,000. 1,000 is a power of 10. Okay, so we have 10 to the x plus 4, but 1,000, you'll remember, is 10 to the 3. Okay, if you don't know that, you go 10 squared, 10 cubed, 10 to the 4th until you get to 1,000. Okay, these ones are set up so that they're going to be the same. So 10 cubed, then x minus 4. Okay, now remember how we do this. The exponents multiply, and because that's a binomial, the 3 distributes to the x and to the minus 4. So this is 10 to the x plus 4 equals 10 to the 3x minus 12. Now that the bases are the same, we can actually drop them. And so x plus 4 equals 3x minus 12. And that, you've been solving this kind of algebra for, well, it must seem like forever for you guys. So minus x, so that's 2x, plus 12, plus 12. So 16 equals 2x. So that means that x equals 8. Okay, so there's our answer. We can substitute it. So if you just grab your calculator out and go, so if x is 8, we go 10 to the 8 plus 4, so 10 to the 12. Okay, that's a pretty big number. And then 1,000 to the 8 minus 4, so 8 minus 4 is 4. So 1,000 to the 4, and we type that in, that's going to be exactly the same number. Go ahead and try it if you don't believe me. Okay, B, if you look at this, so you got 25 and 125. Okay, well, it won't take you very long to recognize some of these. These are both bases of 5. 25 is 5 squared. And when I substitute bases like this, I put them in brackets. So 5 squared to the 2x. So 125 is 5 cubed to the x minus 1. If you don't know that, then again, you should recognize the 25. You should at this point in your math career. But then you go 5 squared, 5 cubed, 5 to the 4th, until you get the 125. And of course, it doesn't take you very long. Okay, so then the exponents multiply. So this is going to be 5 to the 4x. Okay, and then this one's going to be 5 to the 3x minus 3, right? That 3 distributes to both pieces. Okay, now that the bases are the same, we can drop them. So then 4x equals 3x minus 3. So then, of course, minus 3x minus 3x. So x equals negative 3. Okay, go ahead and verify that. Type that into the equation. Of course, you see that it is equal. Awesome. Okay, good, good. For C now, let's just scroll over. Oops, there we go. Okay, so 8 to the x plus 2 is a quarter to the x plus 3. Okay, now, again, don't worry about the quarter. We're looking at the 4 and the 8. Okay, we're trying to figure out a common base for those. And of course, that common base is 2. So 8 is 2 cubed. So 2 cubed to the x plus 2. Now, 4 is 2 squared. Now, the problem is it's actually 1 over 2. Or sorry, pardon me, 1 over 4. So we want that to flip. We want the base to become 4 over 1. Now to do that, we just make a negative exponent. So instead of 4 equals 2 squared, we say 1 quarter equals 2 to the negative 2. See how we incorporate that negative exponent? Just to make the base flip. So 2 to the negative 2 to the x plus 3. So now the bases are the same. So before we drop them, we actually have to do this distribution. Okay, so this is going to be 2 to the 3x plus 6 equals 2 to the negative 2x minus 6. Okay, now that we've expanded out the exponents, now we can drop the bases because they're the same. So 3x plus 6 equals negative 2x minus 6. Okay, so add 2x to each side. So that's going to be 5x, and then minus 6, so 5x equals negative 12. So I'll write that again. So 5x equals negative 12 divided by 5, and x equals negative 12 over 5. Okay, if you really feel like it, go ahead and check that into both sides of the equation, and you can see that they work out to be the same decimal. So, yeah. D, 121, 2x minus 5 equals 1. Well, I'm going to introduce a little trick to you guys so that you can see this better. Now, 1 gets to be an awful lot of things. Hopefully you remember that anything to the 0 equals 1. So anything to the 0 equals 1. So really, if I want the same base here, I can say 2x minus 5. I can say that that is 121 to the 0. Does that make sense? Because 121 to the 0 is 1. Okay, awesome. So now the bases are the same, so we can cross those off, and you end up with 2x minus 5 equals 0. So plus 5, so 2x equals 5, divide by 2, and x equals 5 halves. Okay, awesome. So that's that one. Okay, and then the last one here. Okay, again, I think I have enough room here, so I'm going to give it a try. Now, with questions like this, see how we've got this 1/9 that has the exponent on it and this extra 21 and 7. We are going to isolate the exponential part, so that means dividing by the 21. Okay, just get rid of it. Okay, and watch what happens because it's awesome. So we get, I'm going to write over here just so I have enough room. So 1 over 9 to the 4x. Now 7 over 21 is 1/3. Oh, do you see it? Do you see it now? Because 3 and 9 are related. Awesome. Okay, so 9 is 3 squared. And I don't have to use a negative anymore because the 9 and the 3 are both on the bottom. So 1 over 9 is the same as 1 over 3 squared. Awesome. So now this gets to be 1 over 3 squared to the 4x, okay, equals just 1/3. Okay, well that's nice. So we work that, okay, two exponents. So this is going to be 1/3 to the 8x equals 1/3. Now remember, the exponent on just the 1/3 is 1. Oh, so now that the bases are the same, they can drop. So then 8x equals 1. So then x equals 1/8. Okay, I know this part is a little bit heady again, like there's a lot of thinking, a lot of kind of previous math, but I know you can do it. Okay, and there you have it. So I'm going to make that a little bit smaller again, just so we can fit a little bit more on. And there you have those examples. Okay, we're just about done. The other way to solve these is graphically. To solve graphically, either graph each side of the equation sign, or each side of the equal sign individually, and find where the graphs intersect, or rearrange the equation to get all terms on the same side and see where the graph crosses the x-axis. Okay, you've been doing this for a long time, including in Math 30-1 already, so this isn't anything new. Okay, now this method should only be used when the bases can't be made into each other. So let's say you had a 5 to the 2x and equals, I don't know, let's just say 10 to the 3x, something like that. Just made this up, it's not going to work, so don't fret about it too much. But the thing is, you can see that 5 squared is 25, okay, and there's no smaller numbers, powers that go into 5 and into 10. So the bases aren't going to multiply to work out. So this would be a graphing one. Okay, now of course you'll see we've picked some very obvious bases here to work with. Okay, so for the example, solve the following for x, round to the thousandth. So that's 3 decimal places, 0.00, so this decimal place, 3. All right, see what I mean by obvious? There's a 5 and a 3. Those are quite clearly, no powers of those are going to equal. It just doesn't work. Okay, so when we graph these things, okay, so we graph y equals 5 to the x, and that is an exponential growth question. It has y-intercept of 1, so it kind of looks like this. Okay, 1, 2, 3, 4, 5, so up there. Okay, anyways, here we can expand that out. So if you change your windows on your graph, kind of looks like that. Okay, the other graph, the 3 negative x plus 2, it kind of looks like this somewhere. Now look, I have drawn a very not accurate graph. Okay, this is what your calculator is for, but this is the idea. It kind of looks like that, and you find that intersection point. And remember, you only want the x coordinate of that. You only want the x value. The y value doesn't matter. Okay, so you find the intersection, and it works out to 0.811 to 3 decimal places. Okay, so there you have it. Just graph both sides, find the intersection. Done. Now, we put b on because, look, b, there's a power 4. 2 can also be power of 4. So this does work even if they are bases that can be turned into one another. It's not a big deal. Okay, so we get 4 to the negative 2x. When you graph that one, you get something that looks like, okay, graph that on the calculator, and you get something that looks like this. Okay, so that's 4 to the negative 2x. Okay, and then you get another graph that looks, oh, I'm sorry, the asymptote. I gotta graph that better. Like it doesn't, these sketches don't have to be perfect, but they should be close. Okay, kind of looks like this. Okay, the asymptote is shifted down a bit. Okay, and then it looks like that, and kind of in there somewhere. So they intersect around there. Again, these are just sketches to kind of show you kind of what you should see on your calculator. Anyways, you find that intersection point and x equals 0.6. Okay, and we said nearest, so that's exact, so 0.600 if you're really picky about the thousandth, but that did work out to pretty exact. So we're all good in that sense. And so you have two ways of doing this. You can make the bases the same, or you can graph them. So I want you guys to practice this. Okay, on page 364 of your textbook. So there's the numbers. Do at least that much. Okay, you can always do more, but remember, answers are in your textbook, and it's best if you print these pages from the workspace card, because then you can write all over them. Either way, we are done chapter 7. So what I need from you guys now, okay, so do this practice, then you have a formative assessment on all 3 sections, all of chapter 7. Then you have a curriculum review, that's the one for marks, the assignment for marks. And then you have a chapter quiz, okay, chapter 7 quiz. So you've got a few formative and summative assessments to do. So good luck, and watch these again if you need. Make sure you do all the practice, because that's where you cement the ideas. Thanks. We'll see you next time.